be yourselves and be fine. I don't mind if you ask questions and everything, even if I'm recording. I kind of forget about that. So, till the end. Okay, who has seen these before as far as exponent properties? You did visit this a little bit in Math 1. Is this correct? Maybe you've seen some of it. You're not sure what it is yet? Okay. It might be a little of all those things. Now, a lot of teachers will teach these exponent properties just with the shortcut. Let's say, well, if you're dividing two values, two like bases with exponents, you're just going to subtract them. Okay. Now, that's fine. That's fine. But then you have what? You got to have 7 different shortcuts you have to remember. And I'm not into just having you memorize things. We're going to use the expand method to know these rules no matter what, even if you're on the SAT and you don't remember anything about them. Okay, we're going to be able to find them every time. It's going to become more intuitive. Okay, so let's look at this. The expand method, I'll just kind of clarify to start. The expand method, if I had x to the 3rd power and I expanded that out, what would I get? X times? I think this might be a step behind us, so I'm just going to throw it up. Step before or behind, if this reminds you, perfect. Okay, so x to the 3rd expanded is just x times x times x. Okay. Now, I'm going to leave these two for the end because some of these properties help us prove these. But looking at this as the product of a power property. So we're just talking about the product of a power property. Here's what this would mean. It would be the same as if I had x squared times x to the 3rd. Okay. Now, you again may have learned the exponent properties and just the shortcuts to this. What do you do with the exponent? Who knows the shortcut to this? Who knows the shortcut? What do we do with the exponents?
The square root will be 2 plus 3.
Good, good. So you're saying that the shortcut is, well, just add those together, right? But then you have to memorize that. Okay. The expand method will find all the rules, so let's even forget that we know this. We'll find that at the end. What is x squared expanded? X times x. What is x to the 3rd expanded? X times x times x. Okay. Now we just have 5 x's. We have x times x times x times x times x. What does that give us? X to the 5th power. Right? Expand method, we're going to find all the rules. Now that we've found that rule, what do we really, for the shortcut, need to do with our two terms with like bases, same base, so we can deal with them in this way? We would just have to add those two exponents. Okay. But again, the expand method, don't even try to memorize them. Don't try to memorize them. They'll come naturally. But when you have to do this, this is also expand form is how I'll do more complicated factoring. It is helpful for that too. Quotient of a power property. What if we have this? Now again, last year you may have learned the shortcut. You may know the shortcut. But if we have x squared divided by x to the 3rd, we forgot everything. It's the day of the SAT. Expand method. Expand it. Expand the top, expand the bottom. Find your simplified answer, and then show your neighbor. See what they think. If this feels a little too simple, it's just because I'm starting with basically the bottom part of our pyramid. You don't even need to know the shortcuts in order to solve this. So check with your neighbor. You can talk. You can talk. Check with your neighbor. Want to hear some talking? Not whispering. You can actually talk. It's fine. There you go. Right. So we're going to end up with all positive exponents, just so you know. We're not going to change anything to a negative exponent. You could, but we're not going to end with that. Yeah. It's always more simplified if it ends up with all positive exponents. Okay. So Luciano, help me out. X squared, we said, is x times x. X to the 3rd, x times x times x. What can we do? What is x divided by x? What is that equal? Anything divided by itself is 1, right? That's why, essentially, when we cancel out, when I cross out an x, I'm saying that that is equal to 1 because 1 in multiplication is going to make it stay the same. What's going to happen between these two x's? Those also equal 1. So what is my answer? 1 over x. Okay. I do want our answers to have all positive exponents. So here we have a positive exponent. I wouldn't shift it. And when I teach this up here, you'll see that I could have shifted it, but no, I want them all positive. I want to get rid of negative exponents. Okay. Let's see. Power of a power property, which we're looking at just x to the third squared. Okay. Oh, what did we do? What did we do with our, what would our shortcut be if we had to kind of describe our shortcut for the last problem here? What did we do? 2 minus 3, we'd subtract. Okay, that's a shortcut. Again, you can forget about the shortcuts if you want. What does this mean? What is x to the third? Let's expand x to the third first. X to the third? X times x times x. So x times x times x, but that is being squared. So what is the other part of that going to be? I have x times x times x. That's x to the third. Square that. You see? Essentially, I just have my x to the third multiplied by itself in expanded form. Now, if I multiply 6 x's together, then I get x to what power? 6. X times x times x times x times x times x, x to the 6th. So what would our shortcut be if we just wanted to like affirm that we got the shortcut? Yeah, you would just multiply those exponents together. Again, expand it, and it will start to become intuitive. Or at least you won't have any doubt. And sometimes it's nice. Math is certain in some ways. It's nice. All right, power of product. Let's see. What if we have, I'm going to use x and y. And I'm going to square it. It's x over y squared. So you're doing a power of a product. Oh, wait a minute. That's right. That's the next one. My bad. Let's start over. X, y squared. X, y squared. Okay. Now, x and y, we can't multiply those together to make, to do much more. We can't combine x and y. It's just going to be x times y. But now, expand method, we know that this value here is being squared. So what else should I multiply here to show the whole thing? Times x times y. Reorganize that. Remember that 2 times 3 is the same as 3 times 2. The order within multiplication, it doesn't matter which is in front. So I can multiply x times x, x squared. I can multiply y times y, y squared. And there's my answer. So I like to think of this one as, the shortcut would be to think of it as distributing it. Lastly is x over y. Let's do to the third power. X over y to the third. All right. We know that's xy times xy, right? The third power just tells me whatever is the base is just going to be multiplied by that same value that number of times. X over y to the third, x over y times x over y times x over y. All together, x to the third, y to the third. Okay. So I think of that as pretty much this 3 is being distributed to the top and bottom. Okay. So throughout my lesson, I like to get some feedback. It helps me kind of adapt as I need. Thumbs up means all good. In fact, it might be too slow, just good. Thumbs sideways, I might need another example, might have a question. Thumbs down happens occasionally. That just means I missed something. If it's thumbs down, I need you to ask a question when I come around for sure. But I might do another problem. So let's do it. Thumbs up, sideways, down. I need all the thumbs up, sideways or down. Let's see. No shame. Remember, I don't care if you know it. I care if I can teach it to you. No, that's not right. Don't listen to that. Okay. How about for the pace and the speed of this? Thumbs up, sideways, down. How do you feel about that? We're good? Thumbs down would mean we need to go faster. How do we feel about it? We're good. Okay, we're balancing. All right. We're going to step back to these. This is the main part of the lesson, so don't worry if your brain's getting full here. Zero exponent property. When I have any value raised to the 0 power, what do I end up with? It seems like I should end up with like 0. Right? But what do I end up with? Who remembers this? 1. It's weird. But here's how I can prove that. I'm going to prove it using the quotient of a power property. Okay, so watch this. If I have, let's see, if I have x to the second over x to the second, first off, right away, can you see what that answer would be? What's that going to be? What's this? It's going to be 1, right? Anything over itself is 1. But here's the deal. What did we learn about our quotient rule as far as our shortcut? It says, what do we do with those exponents? We subtract them. What is 2 minus 2? Which equals x to the 0, which we know equals 1, because we started with an expression, x squared over x squared. We know that's 1. We use the quotient rule here, knowing we can subtract our exponents. 2 minus 2 is 0. Since this originally equaled 1, and we just deduced that it's x to the 0, we know that x to the 0 equals 1. That is like, without using some way far ahead of us math, that is the best explanation. You can see it a little better with the quotient of a power. Okay. Or you can just remember, anything to the 0 is always 1. Always, always, always 1. I don't care if it's this. 271xy squared to the 0, I don't care. It's 1. The entire term is applied with a 0 exponent, 1. Okay. Now, right here, with negative exponent property, here's how this works. We're going to spend a little bit of room over here, time with this here. All right, if I have a to the negative 2, I want you to talk with your neighbor just to see if, what we do know about this. What am I going to do to get rid of that negative? I always want my exponents to be positive. Don't ever leave negatives in your problem unless you're being like super clever with something. Who needs a hint? No one. I'll give it anyway. And if you know how to do it, I just want to remind you, we're not doing the reciprocal. It's not what we're doing. We're not doing the reciprocal. That would be a different situation. It's one term with a negative exponent. All right, for Starburst, who feels like they know this? Maybe you never learned this. Teasing Starburst. No. Have an idea? Neat?
Yeah.
What's your idea?
So a to a and negative 2 equal a1.
Let's see. I don't see actually. You guys haven't learned this. Unanimously, I just discovered this, and it's fine. Can your partner help you out maybe a little bit? What do you think?
1 over a exponent.
Is that what you're saying?
To the second power.
1 over a squared. You kind of remember that now a little bit? Okay. It's okay. This isn't super mysterious. I'm going to give you another example here. What if we had this? X to the negative 2, y to the 6, z to the negative 3. First off, you know that I hate negative exponents, so I want you just to circle the ones that we need to change. We don't need to change everything. There's one up here we don't need to change. But if I had this situation here, I know I need to change the x, and I need to also convert the exponent for the z. Why? Because we don't like negative exponents. So I'm going to go ahead and put a fraction here. What should we not touch? What's going to be in the same place? Very good. Y to the 6th. And what did we need to do to these two terms, these two values here? The entire thing is a term. What do I do to my x variable and my z variable? What am I going to do with those two parts? x to the negative 2 is moved down. Now it becomes x squared. Z to the negative 3 moves down. Now it's z to the third. Done. I'm going to do one more, but it could be a challenge problem, but it's just going to be another practice. Because I know you can do this now. Okay. So let's see if I can fit it right here. A squared, b negative to the negative 4th, c to the negative 6th. Oh man, I'm kind of sorry, kind of not sorry, because I'm doing that. Oh, no. Yeah. No poisonous water. Poisoning the teacher. We're okay. No one has glare issues. This room's pretty good with that glare. All right, don't sweat it. We know that when we are changing from positive to negative, we're just taking that term that we need to change. We're putting it on the other side of the fraction. My hint is it works either direction. Move it here, or okay. Now. First, circle the variables that are not in final form, the ones we need to deal with right here. Let's see. There we go. So I know I need to move what? Name them out for me. B, C, E. These guys got to move here. This one's got to move there. That's going to change the valence of that exponent from negative to positive. Okay. It works either direction. So what's left up, or what is, originally we could see these. These are going to be, they're going to be left. We don't need to change them. Their position's fine. Okay. We change this 4 to the negative, b to the negative 4, it becomes b to the 4th if we move it where? B to the 4th. Always alphabetical order. Cleaner. All right, how about the c to the negative 6? Move it. C to the 6th. How about e to the negative 3? Where are we going to move that one? That's the thing, the reason I did this. It's no big deal, right? You move it to the other side of the fraction, either the top or to the bottom, and then this is going to become e to the 3rd, but it'll be on top. Okay, thumbs up, sideways down for that. It's good, right? You thought it'd be harder than that? Maybe? No, you didn't think it was so hard. It's as easy as you thought. Okay. All right, welcome to the right side of the screen. We have to convert between exponent form. Sometimes our exponents are going to have, it's going to be a rational exponent, it's going to be a fraction. That didn't really help. Does anyone have a neighbor who's obsessed with the leaf blower? No one? Oh man, my neighbor loves it. He loves no leaves on his grass. Every day, but it's like his passion, so I try not to be angry with it. Try to practice that. All right, the exponent in this case is what? It's fraction. Okay. There's a method that we're going to approach what each part of the fraction means every time. We're going to convert the exponent into radical form. Radical. Radical is just the root. And let's see. I'm going to split this a little bit. This goes here. Below that blue line is my key. This key here, it's an old skeleton key. Whenever I draw that, that means that's like a key point, obviously. What do you think it means? Okay. So I use this mnemonic device. Mnemonic devices just help you remember things. You can always remember it faster than just rote kind of details. Power tree is how we're going to remember this, the power tree. Okay. When we have a base to an exponent that is a fraction. The power, just like lightning, is on the top. The power is on the top. The root, just like roots of a tree, are on the bottom. That's where we find those values. Okay. So now if I'm rewriting this, let's say I had let's say if I had 8 to the 2/3. Okay. First off, I know that my base is going to go here. My power is going to go out here, and my root is going to go here. So I want you just to, it's all about spatial positioning. This number represents this in this form versus this other form. So I want you to go ahead and switch this up. Instead of 8 to the 2/3, go ahead and put it into radical form. Base goes inside. The power, the exponent, the power, kind of always goes in that same place up here. The roots go in the root symbol. Okay. All right, so if I rewrite this, let's see. Who's feeling confident in the answer for this one? Someone I haven't called on yet. Someone else. Or someone I called on, you know? Someone I called on. You raise your hand. Put a hand up. Luciano, what do you think?
So it's 8 goes in the middle.
Good.
3 goes in the root.
Right here.
Yeah.
Third root of 8 raised to what power?
The second.
Second power. Okay. That's it. I hope it's a little bit easy to remember because from the fraction, we're trying to figure out which is the power, which is the root. Power's on top, roots are on the bottom. We know that the root is placed in the root symbol. The power, this is where the exponent goes anyway, right? So that's where it's going to go. Base is the number we're dealing with. Okay. So let's do this one here. 2 raised to the 2/3. Go ahead and knock that out real quick. And then check with your neighbor, the person right next to you in your group, to see if they had the same solution. Flag me down if you need a little bit more information. I don't have to extra credit. Take a picture of those. You want me to notes first? I'll switch off each quiz or so. I really like your writing, so take a picture of it. And if you're on Edmodo already for this class, did you switch to this class yet? Then I'll give you the code. But oh yeah. I'll still give you the extra, but if you have someone else take the picture and post it, I'll get you into Edmodo by the end of class. Or you just wait. Okay, who's feeling confident for this? You see in the pattern? It's all pattern approach. Okay. Let's have someone from over here I can call on. But the far 2 rows, what do you guys think? Or I'll take your name again? Ethan, what do you think?
The root would be 3.
The root is 3.
And then the base would be 2.
Base.
And the power is 2.
The power is also 2. So let's put it in there.
So parentheses.
Mm-hmm.
And then the radical sign.
Mm-hmm.
And then the 3 on the outside.
Okay, so the third root or the cubic root. Good.
The root. And then the 2 on the inside of the radical sign.
Mm-hmm.
And then the 2 outside the parentheses.
Perfect. Raise your hand if you got that. Straightforward. We got it. Okay, one more person from the far row over there. Somebody help me out. Veronica, help me out. Please.
Okay, parentheses.
Good.
3 for the root.
Good.
X is the base.
Yep.
Parentheses and outside the power is 7.
Perfect. You guys good with it? Okay. That's a pretty good example of like how I'd run a class. So I mean, you feel pretty good about that. Then that's our first lesson, and we'll just keep going with it. I really like math too. We're gonna do some good stuff. We will spend some time outside launching things, as mentioned. All right. Very good. All right. this is done then. So one thing you'll learn is I'm really big on how many subscribers I get on my YouTube channel. Last year kind of sucked because I had the same kids, like the same kids that are seniors now. I had them 2 years in a row, which was awesome because I already knew them. Less names to remember. But I didn't add like more than like 20 people last year. So make your teacher happy. Maybe one day give me some advertising money by subscribing to my channel. And to all the people just watching at home, I like to yell at them and send them messages at the end. So we're going to tell them subscribe. We're going to subscribe on 3. We could do this, right? Be as loud as you can. Yeah? All right. Subscribe on 3. 1, 2, 3. Subscribe! Come on, guys. Third period is way louder than that. All right, 1, 2, 3. Subscribe! All right, that's better. They heard you. Now everyone's going to subscribe.